Good morning, and thank you for joining us. We're very pleased to present our next presenter, Manish Patel with Qubole. 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 Everyone say it together, Qubole. Good job. Let's give him a warm welcome.
Thank you. Thanks, Trish. Hi, folks. Manish Patel, Technical Director at Qubole. Qubole, I'll talk about that in a bit here. I'm going to be talking about automating big data on AWS with Qubole. Thanks a lot for joining me. A little bit about Qubole. So Qubole is a big data as a service provider. We are cloud optimized. We are the single largest and fastest growing big data as a service provider on the cloud. We run on AWS, Azure, and Oracle Data Cloud. We were founded in 2011 by the pioneers of big data at Facebook. Ashish Tusu and Joydeep Sen Sarma had built the data platform at Facebook and really helped revolutionize how Facebook works with data by allowing proliferation of data and really democratizing the data there. And they did this with a relatively small data team. And some of the learnings they learned, they were able to figure out there, they took and realized that they can really do this and build something special on the cloud, and which is what allowed them to come and formulate Qubole. We are based in Silicon Valley, and some of our investors include Charles River, Lightspeed, Norwest, IVP, and Singtel. So big data is hard. It's still hard. It's been hard for the last half a decade or so. And a recent report by Gartner states that 70% of big data projects will fail by 2018, which is just around the corner. Some of the reasons cited, if you've worked in big data projects, you're probably aware, include lack of skills for people that can run and build and manage and maintain some of these environments. There's a huge amount of complexity when it comes to the number of open source tools that are available in this space, the rapid evolution of these things. Just for example, you look at something like Apache Spark, they've gone through 7 or 8 different versions in just the last 2 years, right? So Qubole's vision is to really solve that. And how do we solve that? It's through automation, right? So Qubole has built an autonomous data platform that self-manages, self-learns, and is context-aware. I'll be talking about some of the details of how we do that. Effectively, we're collecting metrics and metadata about what's happening on the system and analyzing that with AI and turning around and providing insights, alerts, and recommendations back to our users for that, which helps drive down total cost and improving efficiencies, and again, allowing our customers to really accelerate time to value and be successful with those big data projects. Qubole is, as I mentioned, a big data as a service platform. What does that really mean? We're a platform that is built for anyone that uses data. So this is your data engineers, data ops folks, analytics, data science, machine learning use cases. We have interfaces, so we have built-in UI for various persona, notebooks out of the box for data science, machine learning, discovery, a fully baked REST API, SDKs that go along with that for programmatic interface. Of course, ODBC, JDBC drivers for visualization tools and other tools that you might use to connect into the system. It's a single platform for multiple workloads as well. So we have a lot of customers running ETL workloads on Qubole. We have customers that are running ad hoc query use cases on Qubole, machine learning, and much, much more. In terms of the stack and what we provide out of the box, Qubole provides the ability to easily deploy and manage and run Hadoop clusters, Spark clusters, Hive, Presto. We have built-in job scheduling capabilities. We support Airflow, which is a complex workflow management system out of the box. And again, all of this is built and optimized for AWS. It's optimized for the cloud and specifically optimized for AWS by allowing our users to do things like take advantage of Spot instances in a really reliable and scalable manner. Obviously, S3, optimizations around how we interact with S3. The ability to run large heterogeneous clusters. I'll talk about some of that in a little bit. Just taking a look at the architecture of how we do things. It's a really colorful slide here, so I'll try my best to kind of walk you through this. If I look at this, sort of left to right, the user access, right? So out of the box, as I mentioned, a fully baked web UI that caters to multiple persona, whether you're a data engineer or a data scientist. That sits on top of our REST APIs for programmatic interface, and then again, the drivers for visualization tools. This stuff flows over the internet, HTTPS secure connection, to our orchestration tier and management tier. The nice thing about our tier is this is infrastructure we also host on AWS, and it's a fully scaling tier, which means that we have customers that have hundreds to thousands of active users, and we're able to cope up with that level of concurrency because of the ability for us to scale our tier. So our web tier, our orchestration tier will scale along with you. The heavy lifting and the data processing is actually happening in our customers' AWS environments. So what Qubole is doing is automatically spinning up these Spark clusters or Hive or Hadoop clusters or Presto clusters on EC2 in your VPCs. You can run them in a private subnet. It's fully secure. Data being processed off of your S3. So here's something I wanted to mention is that Qubole's architected this with the compute and storage separated, right? So all of our customers are storing their data on S3, and S3 becomes the data lake. And we do this intentionally because that allows us to run ephemeral compute clusters. It allows us to do the elastic scaling dynamically up and down as well. You can run multiple clusters, different shape and sizes, and really geared for the workload, right? So this is a pretty big paradigm shift if you're coming from your traditional converged architecture where you're running everything on HDFS, for example, right? Where in that scenario, you might be kind of forced to shoehorn stuff to fit because that's where your data resides, which ends up resulting in either underutilized compute or memory capacity, or sometimes too busy of a cluster, right? With Qubole, you can run different clusters, and each of these will independently scale up and scale down. Pick different instance types for those workloads. They all are integrated with, in our case, the Hive metastore. So if you're using one of the query languages, Presto, Hive, or even Spark SQL, all of those natively are integrated with the Hive metastore without the users having to worry about configuring anything around that. So I might have an ETL workload that produces data sets, builds partitions, and I'm using a specific cluster that's designed for that. My ad hoc users come on, and they fire up a Presto cluster. It's automatically got access to that information. So let's talk about the auto-scaling, right? So again, one of the key things that Qubole allows our users to do is really drive down total cost of ownership and effectively use the compute resources effectively. Qubole has built auto-scaling into the core stack. We've taken Yarn and the scheduler there, and I've actually put the intelligence, decision-making criteria, and actual execution of auto-scaling into Yarn itself. At a very high level, what we're doing is, for those of you that might be a little bit familiar with how Yarn and Hadoop work, we look at the pending container queue size. When there's a need to scale up because there's a large queue and we could potentially help parallel process things better, we'll go and get more nodes from AWS, right? We're also smart about how we do that. We look at thresholds to make sure that we're not prematurely getting nodes. Sometimes you have a queue and that might be draining pretty quick. We're doing it intelligently. Scaling up, it's a tough problem, but not a super hard problem to solve. Scaling down dynamically, that's a tough problem, right? So we've also solved that in a number of ways where we can also dynamically start shrinking the cluster size without affecting your workloads, right? Allowing your jobs to run in flight. One of the common problems that we solved was we've got customers that have bursty workloads, as many customers in this space do. You have a burst, a big burst, something that happens that scales the cluster out to 100 nodes. And then you've got a steady stream of small jobs that comes through. You will never get a good opportunity to remove a node because Hadoop is just going to continue to schedule these tasks out to all of the available nodes. We've built something called container packing, which will intelligently start to schedule these containers on a smaller set of nodes, improving the chances of nodes going idle and then allowing us to downscale these nodes. This works really well with now the per second billing that we have in place with AWS. Again, helping our customers drive down the cost. And I'll show you a little bit about what they've actually been able to do in terms of numbers of cost savings. Here's an example. This graph here is really showing auto scaling. This is a screenshot of a live customer's cluster. You can see over time, scaling up with spot instances as well as on-demand instances. Dynamic, that flat line at the bottom there, that's the cluster shutting down completely, right? Qubole will automatically terminate the clusters when there's no activity on them. Again, we can only do this because of separation of compute and storage, right? We can also scale up with heterogeneous node types. On the left-hand side there, it might be a little hard to read, but you can select the types of nodes that you want to run on your cluster. And down below, you'll see that we've selected using heterogeneous node types. This is really advantageous when we start talking about Spot, which I'll talk about in a second, because now you can have a mix of node types to achieve the capacity you're trying to go for, but at the same time, use things like Spot. We use Spot Fleet under the hood, and we'll get the best set of nodes using different instance types to fulfill that capacity and help you keep your costs down. So a little bit more on Spot. So what a lot of users come in when they start using Qubole, they realize they can take advantage of Spot because Spot is great. It's awesome for being able to save against what you would pay for EC2. The trade-offs are, of course, that you might not get the nodes when you need them, and worse, you might lose the nodes when you have them. Impossible to use Spot if you're doing a static cluster running HDFS on EC2, right? Because that's where your data resides. With Qubole, what we've done is we've taken it a step further, or multiple steps further, in the sense that you can not only use Spot and auto-scale your clusters up with Spot, we've actually built intelligence in to help protect you from the trade-offs, right? The first one being not being able to get the nodes when you need them. Well, I can set a timeout on my cluster, right? And it might be more important for me to scale up than it is to save money, right? OK, I'm going to try to save money when I can, but ultimately I want to make sure my users are happy, my SLAs are being met. So therefore, I can set a timeout and fall back to on-demand, right? When I fall back to on-demand, what Qubole also does is, at a later point in time, if those Spot instances become available for the price you're willing to pay, well, guess what? We'll go ahead and automatically rebalance the cluster and use those instances, grab the Spot instances, and replace the on-demand ones. And that's a graph of that happening. Again, this is a real customer graph. You can see the blue line up there where there was some Spot loss, and it flipped and started using on-demand nodes. At a later point in time, when the Spot nodes became available, we, again, gracefully, will replace the on-demand nodes with Spot nodes. Right? So we're doing the right thing here, and again, maximizing how much Spot you can use without disruption to your services. And then finally, with the Spot loss and how we mitigate problems caused by that, that really causes problems when you lose intermediate data sets. Without getting into too much of the detail, we use HDFS under the hood, and sometimes there are transient data sets that exist only on HDFS. When you lose those nodes, you got a problem because you got to rerun your whole job. Not catastrophic because your main data is on S3, but still very problematic. We have a custom block placement policy where if you set your ratios up correctly and use that, you can then basically, we'll keep a copy of the data blocks on an on-demand node. So that if you do lose Spot instances, sure, there'll be a performance impact for a while, but your jobs won't fail. Right? So we use that as a way to protect you from Spot loss. What does this all mean? So let's look at the value here. So this data here is kind of spans 2 years worth, right? So the cluster lifecycle management alone. This is Qubole being able to dynamically start clusters. So you use the UI, you run a query. If the cluster's down, we'll auto launch it. Use the API, we'll do the same thing. If you're using Airflow or the scheduler, we'll do the same thing. And when it's idle, we'll shut it down. This alone has saved our customers $150 million over the last 2 years. The auto scaling, right, that I talked about, that's an additional $121 million. And then the ability to take advantage of Spot, that's $40 million in savings that our customers have gone through over the last 2 years. And just over the last year, there's been $140 million in savings that our customers have seen. Right? One of our customers, Wade Warren, Senior VP of Engineering at Wikia, has cited that they alone have saved $700,000 just by using Qubole. A little bit more on the automation piece and kind of the vision before I wrap up here. So our goal is to make this a fully autonomous data platform. And we look at it in 4 different pieces. The insights, so being able to gather metrics and information about what's happening on the system. We're talking about infrastructure level stuff, so cluster level metrics. Are my clusters being utilized appropriately? We're looking at data level information. Am I using the right data formats? Could I optimize this for using partitioning or better file formats? To the user persona, right? How are we socializing information about data sets that they're working with? So for example, if I'm a user, I could come in and query a data set, but might be the first time I'm working with this data set. We'll present to the user, what are the top users that are using this table, right? Might prompt me to go talk to Bob and ask Bob, hey, Bob, I'm trying to access this data and trying to do this, right? So it just helps improve productivity. Take that a step further and build in alerts, right? So we've got alerts around some of this stuff. And then the recommendations piece is really interesting because we will collect that information over time. We'll run our analytics on it and continuously propose recommendations back to the various personas that are responsible for various pieces of the platform. Right? And then finally leads to the automation aspect that I talked about some of them already, but some of these are also kind of in the works. So that is Qubole, and I think with something like Qubole, it really helps a lot of our customers. Here's a splash screen, NASCAR screen of some of our customers that are using it. As you can see, there's a lot of different verticals involved here. Our legacy has, we started with a lot of cloud native companies that were data-centric, so your ad techs, your marketing tech companies, DataShoe, MediaMath, and so on. We've spanned across and gone into more of the Fortune 500 customers now that are realizing that being data-centric is an important aspect. Turner, Comcast, and so on. So we're in a lot of different verticals and in different spaces as well. That's my time. I really appreciate it. I want to leave you with one more quick thing. We've got a really cool serverless Spark demo, Spark on AWS Lambda. So if you get a chance, stop by our booth. If you have any questions, I'll be mingling around here after this. So thank you.